Okay, so here's all our classes. So main, public static void main, finish. Then I have employee, new class employee, new class animal, finish. Then we new class plant, finish. Then I have a new package com.derived, and inside com.derived I have accountant. Finish. So main employee counted. Now, as I've said, everyone has to be here on time next Monday, because I won't be here next Monday. So 8:30 next Monday, everyone needs to be here. If you're not here at 8:30, you're going to be out. There's nothing I can do about it. So make sure everyone's here on Monday, on time. Okay? And breaks then are going to be quarter to, let's say 20 to 10 to around 10 past 10. And lunch will be from quarter to 1 to around half 1. Is that okay? Just for next Monday. So make sure everyone's here on time next Monday. Now, so we should have all the classes there. Get rid of this. Right. So I'm going to go to the main. Okay, hierarchies. So we start a new section here, section 6.1. So chapter 6, section 6.1. And I'm just saying, right, next Monday I won't be here. So everyone needs to be here on time Monday. Okay, so we're here on 8:30. Okay, right. Now, so this is chapter 6, working set. This is section 6.1. So this is all about inheritance and overriding and overloading and polymorphism and all that sort of stuff. Okay, so we're in the main. We're going to do exam objective 7.1. Describe inheritance and its benefits. Exam objective 7.5. Use abstract classes and interfaces. Okay, so what are the benefits? So benefit number 1. Okay, with smaller derived classes, subclasses, we only need to concentrate on what is unique to a particular derived class. Okay, so your superclass is something that's going to be common to all classes, let's say animal. Then we have mammal. You only do things that are unique to mammals. Then you would say class ape. Then you would do something that's unique to apes. Then you would have human. So you'll only do what's unique to human inside the human class. Okay. So that it allows for you to concentrate on your classes. Okay. What's unique to a particular derived class. Okay. Benefit 2. Ease of modification to common properties and behavior. Okay, it's very easy to change some property, to change some attribute of all animals. You could have 1,000 derived classes, and they're all derived from the animal class. If you put a method in the animal class, that means that that method is available to all types of animals. If you change something about an attribute in the animal class, that means that the attribute is changed for all animals as well, or a new attribute is added. Okay, so it's very easy to modify a lot of different classes. Okay, benefit 3. Okay, extensibility. Okay, code that works with the base class in some hierarchy. 3. Can work with all classes that are added using inheritance data. Now what that means, let's say we have an animal class and we have class mammal extends animal, class dog extends mammal. Okay, we can come along later and add class cat extends mammal. We can come along and go class cocker spaniel extends dog. Okay, it's easy to add classes. It's easy to extend a class. That means you could have a class cat. It could have nothing in it inside itself, but it inherits from mammal, it inherits from animal. That means it already has a load of methods. Okay, it has methods from the object class, it has methods from the animal class, it has methods from the mammal class, even though there's nothing inside it. Okay, that's what I mean with extensibility. It's easy to add classes to, if you have a structure like this, animal, mammal, ape, human. Okay, it's very easy to add a class in anywhere in that chain. We could create another one called reptile. We could do a subclass of mammal called sea mammals. And we could leave that there for a couple of months, and a month, let's say 6 months later, alright, I want to do a class to do with seals. Okay, it's very easy to add to that tree. Okay, so that's what I mean by extensibility. Okay, now benefit 4. So use tried and tested code from a base class. If something works in a base class, it's going to work in a subclass. Okay, so this promotes reuse of good code. Okay, so if something works in a superclass, it's going to work in a subclass. Okay, you spent months doing a particular method and it works perfectly. So then all the other classes that are going to extend that class are also going to have access to that method. Okay, so reuse of good code, i.e. connecting to a database. Okay, so you could have a superclass that connects to a database. All classes that inherit from that class can also connect to a database. Does everyone understand that? Yeah, or connect to a file or whatever. Okay? So connecting to a database, I don't know, let's say finding a route, okay, in GPS software. Okay, so connecting to a database is actually easy enough to do in Java. Finding a route in GPS software is not easy to do. So if you do a method that does that, every other class that is going to extend that method is also going to be able to find a route using GPS software. Yes? Okay. Right. Benefit 5. You can concentrate on specialized behavior of your classes. Now, I have a dog class, right? And we know that it inherits from mammal, which inherits from animal, right? But we don't care. All we have to do then with the dog class is what we put in the dog class is what's particular about the dog. Okay, it allows us, so it's going to take some methods from the mammal class, it's going to take some methods from the animal class. So then we can concentrate in the dog class about what is particular to a dog. Okay, all animals are going to eat, all animals are going to breed, all animals are going to die, so on and so forth. Okay, but you can concentrate in the dog class then is what is particular to a dog. You might determine that there's nothing particular to a dog. Alright? If there is nothing particular to a dog, then guess what? Nothing goes in the dog class. Right? That can happen as well. You might think there's nothing really that's specific about a dog that we need for our program. So then what does it have? It just takes its method from the animal class and from the mammal class. Now this is all done at the pre-planning stage. Right? This is all done at the planning stage. This is not determined as you're typing your code. You have all of this done out before you even look at the keyboard. Alright? Now you do that. One of the easiest ways to, well, I don't know if it's the easiest way, use something called UML. UML is called Unified Modeling Language. They're just diagrams. Okay? You can use diagrams to determine what your classes are going to look like. You can also use something called storyboarding. Anyone familiar with storyboarding? Alright, anyone here a fan of animation? No?
Sorry, what?
Animation? No one's a fan of animation? Okay, well, I am. Alright, now when they're planning, this comes from the animation industry, something called storyboarding. It's where you actually do a series of drawings of what your application does and how people interact with it. Okay, that's what storyboarding is. Storyboarding is drawing out a scene. So storyboarding, when it comes to software development, it can be basically the GUIs, how they're going to look, or it can be how users are going to interact with your program. So how users interact with your program is dependent on what your classes look like. Right, there's a couple of different techniques, or two techniques for determining what your software is going to look like would be UML and storyboarding. Alright, you can use both of those techniques to determine what classes you're going to have, what's going to be inside the classes, what methods are needed. It's not going to tell you how to implement these methods, but it will tell you what methods you need. Okay, it will tell you what classes you need to have. It also will tell you what classes should inherit from what other classes. Alright, so that's all in the planning stage. Alright, so concentrate on specialized behavior of your classes. That means you can concentrate, as I said already, concentrate on the dog class. You don't need to worry about mammal. You don't need to worry about animal. You don't need to worry about cats. You don't need to worry about zebras. If your job is software developer, the team lead comes along, I want you to develop a dog class. All right? You already have an animal class, you already have a mammal class. You see that's inheriting from both of those. So then all you have to do is concentrate on the dog class. You don't give a shit about the animal. You don't give a shit about the mammal. It'll be inheriting from animal and mammal. And you'll probably have to override the methods from the mammal class. And you'll probably have to override the methods from the animal class. But you're still just concentrating on the dog class. So it allows your software as well to be broken up. If you've got a team of 3 people, it's easy to break up the roles as well. So I'll say, Iggy, I want you to look after all mammals. I'll say, Stefan, I want you to look after all reptiles.
Snakes.
Okay. I'll say, so I have another class called fish. I'll say to Roland, I want you to concentrate on sharks alone. Okay. Someone else has already done the fish class for us. Okay. So you will just look at the fish class. You'll see what's in it. You'll see what you have to override in here yourself. Okay. So you can concentrate on specialized behavior of your classes. And what's the last benefit we have here? Benefit 6. Logical structures and groupings. Okay, so when you have your superclass and subclasses, we as human beings, that is how we think. We put everything into groups. Okay. We look at people, they either belong to a country, they belong to a family, they belong to partners. Okay, everything belongs to something. All right, we don't see individual anything. When we look at books, we see a library. When we look at this room, we see a classroom. We don't see its individual elements. All right. So object-oriented program is all about grouping things together in a way that we understand. All right. So inheritance allows us to do logical structures and groupings. As I've said already, animal, mammal, reptile, dog, ape. I don't need to explain that, do I? Okay? You just look at it and you know instinctively what's going on there. Right? It doesn't have to be explained to you. Similarly, when you do superclasses and inheritance and all the rest, you just know it. It comes instinctively to us because that's built into us. Okay, we're born with that ability. Right? Now, machines actually find that difficult enough, believe it or not. So object-oriented programming inheritance is all for us. It's not for the machines, it's for us. Okay? Right. So there's the 6 basic benefits. Alright? Now we're going to do a little bit of programming. So I want us to go to the employee class, please. Now, so here we're going to be doing about different access levels and what's available in what class. Alright? So we're inside public class employee, so I'm going to go public int age is equal to 23. Okay, so this is public. The comment for this is public means that this is available in all classes regardless of where they are. So that means that accountant can access this variable. Does everyone understand that? Okay, accountant can access this variable. All right. Actually, in here, I want us to put in a new class as well. I want you to call it flower. Please. So inside com.gra to be create a new class called flower. Alright, now public means that it's available in all classes and where they're there. So that means as well we can access this variable in all the classes in this package and also all the classes in com.gretb package. So both flower and accountant can access this. So both flower class and accountant class can access this. Now I'm going to create another variable here. This is going to be string name is equal to Tony. Oops. Now, this is default or package level access. It's available only in the same package. So it's not available to classes in a different package. So accountant and flower has no access to this variable. Okay, so we can't access in accountant and flower, we won't be able to access Tony. Now, I want us to open up the accountant class. Okay, and we are going to say public class accountant extends employee. Now, why isn't it giving me? Hold on. Okay, so you have to import com.android. Now, so what that means is accountant now has access to only the public and protected members of this class. Now, members are both methods and attributes. Okay, so it can only inherit the public variables and the protected variables. Okay, it can only inherit the public and protected variables, it can only override the public and protected methods of the employee class. Alright, so if it's not public or if it's not protected, the accountant does not have access to it. Does everyone understand that? If you've got a private variable inside the employee class, accountant has no access to it. If you've got a default level access inside the employee class, accountant has no access to it. If you have a protected variable, accountant does have access to it. If you have a public variable, accountant does have access to it. Is everyone okay with that? Yeah? Right. So, I'm going to go back here to employee. Now, so accountant has access to age. Accountant does not have access to the string name Tony. Okay? The accountant does not have access to this. Now, second here. Now, if I go private int phone number and I put in okay, so this is available only inside the employee class. Okay, because it's private.
It can't start from 0.
And it can't start from 0. Okay? Is that okay there, Brian?
Yeah, but if you need to start from 0, can you make it string?
Yeah.
That's it.
Good. Okay. Now, so that's only available inside this class. Okay. Now, so if I'm going to create an email, but I'm going to make the email protected string email is equal to me@you.com. Okay. So this is available in same package or in a derived subclass, no matter where that subclass is. So accountant is a subclass of employee and it's in the com.derived package. So accountant is a subclass and it's in the com, and it does have access to the email variable. Now, so we can imagine that we're using our classes, we go away for a couple of months, classes are working fine, okay? Everything is grand and our program is working as it should, okay? Our customer, whoever we're developing the software, comes back to us in 5 months after the software has been, you know, when you release software, you're going to be constantly updating it, okay? Your customer says, I want to be able to take in the person's PPS number. Alright? So this is what I'm talking about, why inheritance. And he says that he wants all employees to have a PPS number. Okay? So that means if we want all employees to have a PPS number, the first thing we have to do is we have to create it. String PPS. Okay? So now we want to make sure that every employee has a PPS number. Okay? Now we want to, he says it as well, he wants to make it as secure as possible. Every employee to have a PPS number, and he wants to make it secure as possible. So if you want to make it as secure as possible, you don't make it public. That's the first thing. Okay? Now, the problem with making it string PPS is that's default level access. Okay? And as we can see here, it's disappeared. So if I made it default level access, accountant would have no access to the PPS variable because it's in a different class. Alright? So we don't want to make it public, but that would make it available everywhere. So if we make it protected, it's a good middle ground. That means it can be available in the same package or in derived classes. Okay? So what have we done here? The customer, after a few months of usage of the app that this code produces, the customer decided he wanted to be able to store the PPS number of every person, of every employee. Okay? And make it as secure as possible. Okay? So we created a new string attribute called PPS, and we made it protected, which means that all subclasses can access it, but not all classes. Okay? So only if it's public can all classes access it. And we'll just give it a value of, I don't know, now okay, right, I'm going to do something here and it's going to produce an error and I want you to ask me why. So I'm going to create a constructor. Right, so I've created a blank constructor, right, and that's all I've done. Okay, you should see straight away an error is occurring in the accountant class. Why? So this is what the employee class looks like. So here we have a constructor and employee class. That's it, blank. Okay? That's exactly what it looks like. I go to the accountant class. I'm getting an error. Why? Anyone hazard a guess to say what?
Employee, no, accountant extends employee.
Yeah.
And with no arguments.
I think I know what you're trying to say. And right. Now, remember that when you're in a subclass, it has to call a constructor of the superclass. Okay? It has to call a constructor of the superclass. So here, there's nothing inside here. Alright? There's nothing inside here. When there's nothing inside here, that means there is something called a default constructor inside it. Okay? And the default constructor looks like this. It's hidden. It's a hidden constructor. Okay? That takes no arguments. Okay? However, it has a call to the super constructor that takes no arguments. And I think, yeah, that's fine. We do have a constructor in the employee class. However, the constructor in the employee class is default level access. Okay? The constructor, the only constructor in the employee class. Soon as we create a constructor in the employee class, that then becomes the only way you can create an employee. The only way you can create an employee is by calling the constructor we have created ourselves in the employee class. Okay? And the constructor in the employee class is default level access. So only classes in the same package can access this constructor. Okay? So a way around that is we don't want to make it public. No, private, we make it protected.
Sorry, I always try to protect it anyway.
Okay, so make it protected. So what have I done here? So you have to make this constructor either public or protected, as accountant is in a different package and accountant extends employee, which means we first have to create an employee in order to create an accountant. Super object created first, then subclass object created. If the only constructor in employee is default level access, then the accountant class has no access to this constructor and cannot first create an employee. So this is really getting into Java programming now, because you're not going to be relying on just one class anymore. You're not going to be relying on just one file anymore. What you do in one class is going to affect another class. Could be in another package. Could be in another application on the other side of the world. Alright? So you have to take what's happening in other classes into account of this class. Okay? So you have to make this constructor protected or public. Public would also work. Okay? So protected. Now, so if I save that, accountant no longer has an error on it. Okay? And I always put in the constructors just to show you. So protected employee constructor called. Now, so we're going to create a couple of methods in the employee class, and we're going to see which ones are available in the accountant and which ones aren't available in the accountant. Now, by the way, this is the way this is made at this moment in time. We can't create an employee in the flower class. Does everyone understand that? Right? I'll show you in a minute. Okay. I'm going to do a ordinary method that has no access level. So what employees do, they earn. And there's going to be this way or so. Employee earning. We're going to have another method called work. This is going to be employee working. Right, so these two methods are available to all subclasses in the same file and same package, but not available outside of the com.android package. So this is not available to accountants. So these, are not. Now I'm going to go public void some method employee some method. Okay, this can be inherited by any class anywhere. Now, so I'm going to do a private void private method can only be accessed inside employee class. Okay, so this can't be inherited full stop. Right, so this guy can't be inherited. So any private attribute or private method can't be inherited. Similarly, a constructor, private, can't be inherited. Now the last one, protected void protect method. So this can be accessed from the same package or in a derived class in a different package. So accountant can access and inherit this method.
What do you have inside the protect method?
I should put something in it. Right. So we're now going to go to the accountant class to see what we can and cannot access. Okay. So I go to here. I'm inside the accountant class. So I'm going to create a method called void get variables. Now, so let's have a look in the void get variables. What is this? This is a method. This is a method to test what we can access in the employee class. So if you can access it, what we can access, inherit from the employee class. Right, so we have a look at employee. It can access age. Okay, so try to access age. So okay, it inherits age from the employee class. Age is given a default value inside the employee class of, what was it? 23. Okay, why? Age is a public level access. Okay, has access to age. As age is a public variable.
When we have error in employee, when like we have error in accountant because employee was like not public, not public or protected.
Yeah.
But just now I understand why. It's actually if accountant just extends employee.
Yeah, but the simple fact is, it extends employee, yes, it still only has access to either the public or the protected variables. If it's in a different package, it only has access to the protected and public. It doesn't have access to the default level access. It doesn't have access to private.
Like my daughter extends me, yes?
Mm-hmm.
So she not need to get access to me. What point to get like this? Like, sorry about this.
That's probably not a good analogy.
But like, I understand, but like, employee need to have access to account.
But then
account not need to have access
accountant
to employee.
Well, if accountant wants to get access to all of the variables, with the exception of private variables, you have to put it in the same package. Simple as that. Okay? If you put them in different packages, it only has access to the protected variables and the public variables. The protected methods and the public methods. Okay? So, has access to age as age is a public variable. So look at employee again, does not have access to name. So if we try to print off name, so that goes on name. Okay, so does not have access to name. as name is a default level access variable. So that will not compile. Now, phone number. What's it called? Let's have a look and see what it is. Its phone number is private. So if I try to access phone number, I get an error. So does not have access to phone number, as phone number is a private level access variable, will not compile. Okay, so that won't compile. Now if we look at employee claim,
Yes.
so email, it does have access to email, it does have access to PPS. Okay, so this way. So email is plus email PPS is plus PPS. So it does have access to email and PPS, as both of these are protected variables and subclasses can inherit protected variables. Okay, so this will compile. Now the methods of the employee class. Okay, the methods of the employee class. We'll go back to employee. Can't access there. Can't access work. It can access some method, and it can access protect method. Okay, so I'll say that again. Earn and work. Earn. Nope. Work. Nope. Has no access to either of these. As these are package level. Okay, so neither of these will work. Earn and work are both default package level access. If I go to employee, it will have access to some method. Okay, this is public. I know there's a lot of comments in this, but have to be. This is public, so will have access and will inherit. Go back to so some method is fine. So employee, private method, it's private, can't access it. Okay, so this is a private method, so we'll have no access and will not inherit. And the last one, protect method, We can access that fine. Okay, there's something wrong there. Okay, so this is a protected method, so we will have access and will inherit. Now, we can also create an account or create an employee inside here. Alright? Employee, my employee is equal to new employee. Hold on a minute here. Just give me a second, I'm going to check something. Give me a second here now. Give me a second. Why is this not working? Yeah. Yeah, I need to put that up a minute now, so we're not going right there. But anyway, so these are the variables we can access inside here. Okay, so we can access both. I'm gonna say we can access both default, or sorry, we can access both public and protected methods and variables. Yeah, can we go with that? Okay.
Why I can't access?
I don't know.
I have no idea. Doesn't make any sense.
Well, I'd say download this.
Yeah.
Okay.
You don't pull outside the.
I don't know, Jason. Okay. Now, so that means when we go back to main,
Which one is protected method?
yeah,
Sweet. Probably then.
just download them, Jason.
Yeah.
Download this and shit. Okay. Now, so we're going to go back to the employee class. And this is the end of the employee class. And I'm going to create let's go down here.
Sorry.
Yep.
We have accountant, yes.
Yep.
Great and everything, but how we can access it?
What do you mean? How can we access
Like
what?
I try to access it through main.
The accountant.
Yes, and it's actually like I created employee both equal new accountant. It's wrong. I tried accountants both equal new accountant. It's not allowing as well.
Yeah. Import accountant class.com JRSV. Okay.
Sorry.
Right. So I want to put the employee class. and I want you to create a class secretary extends employee. So secretary words per minute. So what does a secretary do?
Secretary, forgot one letter.
Sorry?
Secretary.
SECRETAR. Oh yeah, RYTAR. Okay. So secretaries, they file away.
Where is employee?
Extends employee.
Class secretary.
Yeah. Okay. Make sure it's outside the employee class. So secretary filing. What else does the secretary do? A secretary types. Now, a secretary is in the same package. So that means it has access to all the package level methods and attributes. It has access to all the protected methods and attributes. It has access to all the public methods and attributes. Do you understand that? Yeah?
No.
Well, I'll explain it. So, okay, so void type. I'll change this to, yeah, type, we'll use. Okay, so secretary. A secretary class. Extends employee and is in the same package as employee. That means it inherits all public, protected, and package level access variables and methods from the employee class. Okay, so accountant was a different package, so it only inherited public and protected. Secretary is in the same package, so it inherits public, protected, and package. Okay, that's the difference. If you're in a different package, you can only inherit. If you're in a different package, you can only inherit. Second. If you're in a different package, you can only inherit public and protected. If you're in the same package and you extend the class, you can inherit public, protected, and package. Okay, so same package, you can inherit three. Different package, you can only inherit public and protected. Yes? Okay, to prove that we can, I'm going to access, scroll up here, we can access the age. Okay, age is public plus age. Go up here, I can access the name. Name is default. I can access protected. Email. Email is protected. Okay, now we can't access private. What's private? Private is phone number. Okay. Phone number is private. So I put it in here. That gives us an error. Okay. Cannot access private variables. Same thing goes for methods. Private variables. Okay. Same rule as above for methods. So if you want to override some methods, you can't override a private method. You can't access a Science Ed class. You can only access a protected, a public, or a default level method if you're in the same package. You can only override a protected or a public method if you're in a different package. Yeah, go on. Yeah, so where are we? Yes. So we're in the employee class. Okay. So in the same class, secretary can access both. This is public. This is package. This is protected. Okay. Can't access private. Same rule for public. It can access the public methods. It can access the package level methods. It can access the protected level methods. So we have a default method, earn. Okay, can access that. This is default level access. We have a public method called sum method. Public. We have a protected method, protect method. This is protected level access. This is public level access. And we have a private method. We have a private method called private method. We don't have access to that. Okay. Private level access. We have no access. Okay. So we can see in derived classes in the same package, you can access public, default, and protected. Yeah. Okay. Right. Now, so this is class secretary extends employee. We are going to have class fireman. Extends employee. So fireman needs safety qualifications. I know it's long, but so what does a fireman do? He rescues people. Okay. I'm gonna just say fireman rescue. He also extinguishes fires. Just goes here. Extinguish. Okay, and we are going to have, oops, now, see what I've done there? I have it inside another class. I don't want that. I want to make sure it's outside the class. Alright. So this is end of secretary class. And this is end of fireman class. And so we're going to have a class oil rig fireman extends fireman. Okay, this is even a more specialist form of fireman. Okay, so an oil rig fireman needs to know how to swim. An ordinary fireman doesn't necessarily need to know how to swim, but an oil rig fireman does need to know how to swim. So here we have an example of specializing behavior. So comment for this is, you can specialize as much or as little as you want. Okay. Now, if there's going to be a specialized version of oil rig fireman, then oil rig fireman, then you can do that. So you can specialize as much as you want. Now, the advantage of specializing is that your classes are going to be a lot smaller. All right. The more specialized your class is, the less code is going to be inside that class when you think about it. All right. Because there's going to be less that's distinctive about. So you could have class oil rig fireman. You could have class North Sea fireman extends oil rig fireman. You could have class, where else in the world? Caribbean fireman extends oil rig fireman. Now it's totally up to yourself, or you might just determine that fireman is enough for all of them. Alright? Now, but the more you specialise, the less code you're going to need inside here. Do you understand that? It makes sense. Yes? Okay? The more you specialise, the smaller your classes are going to be. And small is usually pretty good. Okay? Now the alternative to that is having one big class called employee. That would have to encompass everything to do with every employee, which is literally impossible. Okay? So you should be able to see that inheritance allows you to break things down. I think the technical term is something called subsidiarity. That means just breaking things down. Alright? So you might determine that I just have employees. That's fine. That's what you determine. That's what you determine. If you've got many different types of employees, you might determine I want different classes. It's totally up to yourself. Okay? And you could have different subsections of employees. Class financial extends employees. So financial would encompass accountants, HR, product managers, whatever else. Okay? So how you break up your classes is up to you. Any questions on that? No questions? Okay. So now we're going to, and as well, how many methods does oil rig fireman have? Count them. How many does it have? If I create an oil rig fireman, how many methods can you call? Right, so you can call swim. So I'm going to count them up myself. Okay, I think it's 7. Okay, so you can call oil rig swimming men swim. Okay, so you can call swim. So I'm going to write them out. So you can call swim. The first one. Okay, so that's 1. You can call extinguish and you can call rescue because they're both default double access. So you can call rescue, and you can call extinguish. So we can see you're going from specific to more general. Can you see that? The methods from the superclass are going to be more general and applied to more people. So swim from its own class, rescue and extinguish from firemen. So then we go up the chain. It doesn't, yeah, doesn't minute now. It doesn't extend secretary, so it doesn't have type, it doesn't have file away. Now, it does have access to protect method because it's in the same package. Scroll up the screen. It doesn't have access to private method because it's the private method. It does have access to some method because it's public. Scroll up the screen. It does have access to work because it's default level access. Scroll up the screen. It does have access to airmen because it's default level access. Scroll up the screen. It does, so it has 1, 2, 3, 4, 5, 6, 7. It has access to 7 methods. It has access to one of its own methods, which is swim, and it inherits rescue and extinguish from firemen. It inherits air and protect method, some method, and work from employee.
Sorry, but the secretary, it's not private, protect, not private.
Doesn't matter because it's not in the chain. Because think of the way it works. So you have employee. Okay, and we have fireman extends employee. Then we have secretary and extends employee.
So it's no way with
There's no connection.
Typing.
No. A fireman can't type.
Are you sure?
He's too busy holding his hose. Okay? So, the only connection between firemen and secretary is that they're both employees. That's it. But there's no inheritance relationship between firemen and secretary. Okay? There's no inheritance relationship. Now, they both have an earn method, they both have protect method, they both have sum method, they both have work method. So they both have methods that are common to employee, but there's no direct inheritance relationship between fireman and secretary. Okay? Now, when you look at that, again, it all makes perfect sense. You don't even need to be told these things. You can work it out from looking at this. Okay? Any other approach rather than inheritance is incredibly complicated. Alright?
But so let's say class secretary extends employee and inherits fireman. It can be like
No. So no, you can only inherit from one class. You can't inherit from more than one class. So secretary extends employee. You can't extend employee and fireman. Okay. Well, if you want to do that, what you would do is you put secretary down here. Now secretary extends fireman, fireman extends employee. So it takes methods from employee, it takes methods from fireman, and has its own methods. Okay, but secretary is not inheriting from fireman. Secretary is inheriting from employee. So any method that is unique to fireman and any method will not be available to secretary. Any method that's unique to secretary will not be available to fireman. Okay? Any method that's an employee will be available to both fireman and secretary. Okay? So it's inheritance. When you look at that diagram, you know automatically that, yeah, it's going to have some common features, but it's not going to have everything. that each one has. Okay?
But it's no possibility to call because, like in real life, okay, I'm a student and I'm a cleaner.
Well, all you have to do is, if you want them to have the same methods, all the methods that you want them both to have, you put them in the employee class. So if you want fireman and secretary to have all the same methods, all the methods, you put them in the employee class, then they will both have the same methods. Okay? So there's several ways of doing it. You could also, firemen implement, now you can't allow multiple inheritance, you can allow multiple implementation. You could make secretary an interface. Alright? And believe it or not, that's probably a better solution. Okay? So fireman extends employee, implements secretary, implements, what else could it implement? Secretary, secretarial skills, IT, what else could you want to know? Lorry driving. Okay, so fireman extends employee, implements secretary, IT, lorry driving. Okay, well, implements is an interface. Okay, you implement an interface. You extend a class. Okay, now, so we have our classes done out. Okay, and our classes look like this. We have employee, we have secretary, TLY, Jesus Christ. We have fireman, I should say fire person, oil rig, fireman. Okay, maybe, I don't know, just draw that out or whatever, but just keep that in mind. Okay, so you have to keep that in mind. Now I have to get rid of it. So you have employee, then you have fireman and secretary, then you have oil rig, fireman extends fireman, fireman extends employee, secretary extends employee. Okay, any methods that are unique to fireman will not appear in secretary. Any methods that are unique to firemen will also appear in oil rig firemen. Any methods that are unique to oil rig firemen will not appear in firemen, will not appear in secretary, will not appear in employee. Any method that appears in employee, that's public, dependent on where the other classes are. So methods inside employee, let's say public methods inside employee, can be accessed by all other classes that exist. Okay? Now, so I am going to create a couple of these boys. Okay? So, take that lad out because I don't want those two. So, I am going to go employee Eddie is equal to new employee. So that's an employee reference to an employee object. I'm going to go employee Etna is equal to new employee. Then I'm going to go fireman Sam is equal to new fireman, and secretary Sean is equal to new secretary. Now, so here we have 4 different, and actually I'll do another one. Oil rig fire man Chardon is equal to, or sorry, Olivia is equal to new oil rig fire man. Okay, hold on. I think I did something wrong there. Give me a second. I spelled it wrong. That's it. Hold on. Yeah, spelled it wrong. Now, so we have 5 objects. Okay. We've got 2 employees, a fireman, a secretary, and an oil rig fireman. Yeah?
Do you import it? Fireman, secretary.
Yeah, it is. And then you don't need to import them. Okay. Okay. Alright. Now, in the employee class, we're going to create a new method. Okay. In the employee class, we're going to create a new method. Now, so we're going to create this method in the employee class. We're going to make it public. Alright? That means it's going to be inherited by every other class. Yes? Okay, right. So, and this is just showing you how easy it is to modify the classes. So, I'm going to go down here. So, we are going to create public. I'm going to call it send invitation. And this takes an employee EMP. Now, it's going to return an employee. So, public employee send invitation EMP. Now, when it's returning an employee, that means it can return an employee or it can return a subclass of employee. Does everyone understand that? Alright? When it's returning an object, it means it can return that object or a subclass of that object. Or another way, fireman is an employee, so you can return it. An oil rig fireman is an employee, so you can return it. A secretary is an employee, so you can return it. An employee is an employee, so you can return it. But what I'm going to do is, when this method is going to return a new fireman. Now, so this method can return, I could have put in new oil rig man. No, new oil rig fireman. I could put in return new employee. I could put in return new secretary. Alright? Could be any one of those. So it can return, when you have an employee, that means it can return an employee or subclass of employee. Likewise, in this method here, this method can take an employee or a subclass of employee. Okay, so you can send it an employee, you can send it a fireman, you can send it an oil rig fireman, you can send it a secretary. Okay, so this method here can take any type of employee. Alright, and it can return. Now here I've said return a fireman, but it's legal to also say return new employee. So I'll just comment this out just to show you. I could also say return new secretary. Also valid. Okay, so you can return any type of employee, because I've said here public employee, it's returning an employee. Now what I'm going to do inside the method is, as it can be any type of employee, we don't know what it is. Alright, so we want to guess whether it's a employee, fireman, an oil rig fireman, or secretary. Okay, and how we do that is this way. So I'm going to say emp.getClass. Now that would give us com.android. Let's say it's in the fireman, com.android.fireman, but I don't want the com.android part. I want to just get the name, get simple name. And we're going to say, now, you can imagine a situation here that if it's a fireman, do some sort of code. If it's a oil rig fireman, do some different code. If it's a secretary, do some different code. If it's an employee, do some different code. Okay? This will get what it is. This will get the type of employee. If we know the type of employee, then we can do some sort of code. Alright? But we're not going to do that. All we want to get is to say what the employee is. I'm going to say the word invitation sent. Now we're going to call, we won't be calling this method until after lunch. But before we go for lunch, I want you to write a comment. Okay, so this method can take an employee or a subclass of employee, which means this method can take a employee, a secretary, a fireman, or a oil rig fireman. Okay. Similarly, this method can choose to return any type of employee. Okay. So it can return a fireman, a secretary, can return a fireman, oil rig fireman, secretary, or employee. A fireman, an oil rig fireman, a secretary is an employee. That's another way of looking at it. Alright, now lunch. So we'll be calling this when we come back from lunch. And I will. Okay, so here we are. Now, so I haven't created an accountant, so I'm going to create an accountant for myself. Accountant ND is equal to new accountant. Now, I am going to call the send invitation method using adhere. Is that okay, everyone? So adhere dot send invitation. All right. So now the first thing to notice is this. If I just go adhere dot send invitation, I'm going to send them Sam. Okay. Now Sam is a fireman, so that is going to print off fireman. Invitation sent is what's going to print off there. Does everyone understand that? Yeah. So that's going to print off. So adhere.send invitation Sam. I go to send invitation method. That's going to print off fireman. If I send it an accountant, it's going to print off accountant. If I send it a employee, it's going to print off employee. Okay. Now you can have any sort of code in there that if it's an employee, it does this. If it's a fireman, do this. Okay, so this method can be totally different for each type of employee. All right, all we're doing at the moment is we're just saying what the type of the object is. Okay, so we can send a fireman to us. We can send a employee, Etna as an employee, to it. We can send a secretary to it. Secretary Sean. We can send a oil rig fireman to it. Olivia. And we can send an accountant to it. So there it is. You can see it is fireman, invitation sent. Employee, invitation sent. Secretary, invitation sent. Oil rig fireman, invitation sent. Accountant, invitation sent. Okay? So it recognizes, so this is the one method that can take 5 different objects, 5 different types of objects. So if you can take 5 types of objects, you can also have 5 different methods contained inside the one method. Alright? Now, just to show you one thing. So this very first one here, Eddie.send invitation Sam. So I'll bring this down here. Okay. So just what's Etna? This employee object sent to method. Sean is a secretary. Object sent to method. Olivia is a oil rig fireman object. Andy is an accountant. And Sam is a fireman. Okay. So this method can take many different types of objects. Okay. Now, what's returned from this is, if I look at the method, it's returning a fireman object. Okay. But this part here is the reference. So what it's actually returning is, it's returning an employee reference to a fireman object. Okay, so this is returning an employee reference to a fireman object. So I'll say that here again. So this is returning a employee reference to a fireman object. Okay, all of these methods return an employee reference to a fireman object. Does everyone understand that? Okay, see it here. Go back to employee again. See employee. That means that the reference is returned as employee. The actual object returned as a fireman. Right? That's the return part. That's the parameter list. That's what's sent to it. Okay. So what's returned? It can return any employee object, but it's going to have an employee reference. That means the following. Okay. So Eddie.send invitation returns an object. It returns an employee reference to a fireman object. So I can't do, if I try to do this, fireman Fred is equal to Eddie.send invitation, because this is an employee reference to a fireman object. You can't assign that to a fireman reference directly. Okay, you can't assign it to a fireman reference. Put this here. As this is returning a employee reference to a fireman object, you can't assign this object to a fireman reference. Okay, this will not compile. You can only assign it to, I'm going to create an employee. Enda is equal to ad.send invitation send. Okay, this one here gives you a compilation error. This one here is fine because this returns an employee reference to a fireman object. It's not a full employee, it's not fully one type. Okay, it's got an employee reference to a fireman name, which means it only has access to methods first defined in the employee class. It will not have any access to the methods in the fireman class of its own. Okay, so this will compile. Now, what about if we want this object to be able to use the methods of the fireman class? The methods of the fireman class, one of them is rescue and the other one is extinguish. At this moment in time, we don't have access to extinguish or rescue. So here is where casting comes in. Okay, now you can only cast compatible data types. So this here can be cast to a fireman reference. Okay, if you cast this to a fireman reference, you then have a fireman reference to a fireman object, which means you will have access to the methods extinguish and rescue. Just to prove it. Right, employee inda is equal to ad.send invitation. If I go inda dot rescue, does not have access to it. He also does not have access to extinguish. Okay, because it's an employee reference to a fireman object. So what you do is you cast it. Now you can only cast to compatible data types. Okay, you can only cast compatible data types. So how we do this is fireman Fred is equal to fireman Eddie dot send invitation Sam. Now that works. Okay, because this guy here returns an employee reference to a fireman object. You can only cast compatible types. Now this is a fireman object, so you can cast the reference to be a fireman. That means that Fred is now a fireman reference to a fireman object. Okay, all casting does is it changes the reference. It does not change the object.
So I'm confused. Isn't a fireman being returned? So what is it classic?
No, but see what it's returning is it's returning this. That is an employee reference.
Oh, it's because you're attempting to assign it before it's.
Yeah, because
Yeah.
what I've done with the method here is that I'm returning it as an employee. So that's an employee.
Oh, sorry. Gotcha, right,
Yeah.
right.
So it's an employee reference to the fireman object.
You only get the employee part of the
Yeah. Yeah. Okay. So you can only cast compatible data types. And all casting is doing, the object has to be the same type. Okay? The object is already a fireman. Now it's an employee reference. So all you're doing here is you're changing this guy here to a fireman reference. It's already a fireman object. Okay? So all casting does is it changes the reference. Because we've seen up here, this gave us an error. Because you're trying to assign a... Sorry, no, up here. This was an error. Okay? Because this is an employee reference. Okay? It's an employee reference to a fireman object. And you can't assign, if that's an employee reference, you can't assign it to a fireman reference object. Alright? Unfortunately, this is what the next 2 weeks is all going to be about. There's going to be an awful lot of, you have a superclass reference to a subclass object. That's what inheritance is all about. There's going to be a lot of that. When we come to lambdas, you're going to have an interface reference to something called direct implementation of a method inside that interface. Quite a mouthful. Alright? So, we're going to have a lot. You're going to have a lot of this certainly now. Casting. General rule of thumb is you shouldn't use it too much, but in this situation you have to use it. Okay? If you want a fireman that's going to be able to access the extinguish and the rescue method, you have to do this. Any questions on that? Now, I know it's a lot to take in, but watch the video again. Have a look at the code. You can see that this one does not work. Oh, that's the wrong one. Sorry. That one. So we have. I'll just take out that. That there. Fireman Fred 80 dots in the invitation Sam. Okay. The reason that doesn't work is because that is an employee reference to a fireman object. Okay.
So in last one we made him fireman.
We changed the reference of that to fireman. It is a fireman object, so you can only cast compatible data types. Okay, so put it here. This method returned a employee reference to a fireman object. So we can't assign the product of the method directly to the fireman reference Fred. Okay? Because simple reason is it's an employee reference. Okay? That's why you can't assign it directly to a fireman. So what you have to do, you have to cast it. The product of the method to be a fireman, which you can do as this is a fireman object. Okay, this guy produces a fireman object, but it's an employee reference. So what you need to do to turn it into a 100% fireman, cast it to be a fireman. Okay, so if I did not cast it, if we did not cast this, you would have a object that could not access the fireman methods rescue and extinguish. Okay, by casting it, Fred can now access rescue and extinguish. Okay, so if I go Fred.rescue, Fred.extinguish. Oops, shit, sorry. Works fine. Okay, up here in the .rescue doesn't work, doesn't have access to it. Okay, because this is an employee reference. AD in the is an employee reference to a fireman object. So Any questions about that? Now, there's an awful lot of that more coming up. Okay? We're going to take our time doing this chapter. It'll probably take us 2 to 3 weeks to do this chapter, but that's fine. Okay? We do have the time. You're going to be quite fed up of me saying superclass reference to a subclass object. Okay? You can have a superclass reference to a subclass object. You can't have it the other way around. Okay? Another way of looking at it. A fireman is an employee. An accountant is an employee. An employee is not an accountant. Would that make sense? If I said an accountant is an employee, you understand that. If I said an employee is an accountant, that doesn't make sense. Because employee is the group that contains accountant, firemen, oil rig firemen, secretaries, whatever it's called. Okay? So, superclass on the left hand side, subclass on the right hand side. Not the other way around. A fireman is an employee. A human is an ape. An ape is not a human, even though I know some that would test that theory. Okay, I think we all do. Alright? Now, casting is not the main thing we're talking about here, but it's just something to show you that you can return objects that have one reference, kind of a superclass reference to a subclass object. Okay? And as I said, there's going to be an awful lot more of this as we're going along over the next 2 or 3 weeks. Okay, this chapter is nothing else but this sort of thing we're going to do. Alright? Now, so just to point out how useful these are. Alright, I'm going to bring these guys down here. Right. Now we can send an employee, a secretary, an oil rig, an accountant, and who am I missing there? A fireman. Yeah? Does everyone understand that? Okay? So it's the one method that can take 5 different objects. Do we see that? Yes? It's the one method that can take 5 different objects. Now, so here I'm going to write in a bit. So I'll put in send invitation Sam. So this is fireman object sent to method. Now it's the one method, but it can take 5 different data types. Sam is a fireman, Ethan is an employee, Sean's a secretary, Olivia's an oil rig fireman, Andy's an accountant. Okay? Now, if I didn't have an inheritance relationship between fireman, employee, secretary, oil rig fireman, and an accountant, if there was no relationship between those classes at all, okay? Bear in mind, we've only got one method here that does all of this. How many methods would I want in total to do this exact same thing if we don't have an inheritance relationship going on between any of the classes? I'll tell you how many. We've got 5 classes. Okay? And in those, each one of those 5 classes, we'd have to have a method called send invitation that would take a fireman object. That's 1. We'd have to have another overloaded method that takes an employee. That's 2. We'd have to have another method that takes a secretary. That's 3. We'd have to have another method that takes an oil rig fireman. That's 4. We'd have to have another method that takes an accountant. That's 5. And we'd have to have 5 methods in each one of those 5 classes. So that is 25 methods. So instead of 1 method, we'd have to have 25 overloaded methods. So by a factor of 25. So that's 25 times less work you have to do by this one method. Okay? When you have an inheritance relationship going on between all the classes, if you didn't have an inheritance relationship, you would have to have 25 separate methods separate overloaded methods called send invitation. And I'm going to show you an example with another class where there's no relationship to the two classes. Alright? So, if you go to the animal class, please.
It's empty.
Yeah, not for now. Now, public class animal. So I am going to, and beneath that, I want public class dog. No relationship to them. Doesn't extend. And inside the animal class, oh sorry, can't be public, of course. So I am going to have int age. I am going to have string name. Okay. Then I'm going to create a method called void eat. And we're just going to say eating. Now, we are going to create a method called take animal. Now, we want to be able to take both an animal and a dog. Alright? So we can create an overloaded method that takes a dog. Okay? So we have an overloaded method, two of them in the animal class, one that takes an animal, one that takes a dog. Okay? Now, if we go to our dog class, okay, and I want dog also to have age. That means I have to declare it again here. I want the dog to be named. I also have to declare it here again. I have an eat method that does exactly the same thing as the eat method in the animal class, but I can't use inheritance or overriding or whatever. It's exactly the same. I have to put in another method there. Now, I want a method inside the dog class that can take an animal or a dog. Alright? So that means I have to do the same thing again. I have to go void take animal my animal, and then I have to
Animal interface or what?
there's no animal interface. Oh, it doesn't extend it, no.
No, I mean what animal is class or
It's class.
ah.
Okay. Void take animal dog my dog. Now that's just with two classes. Okay. If you had an inheritance relationship going on, now I have got four, so you have this one. Okay, so there's no relationship between the two classes. They're two totally separate classes. Alright, no relationship between them at all. But I have a method called take animal. Animal my animal. This is an overloaded method. Dog my dog. So we have two methods in the one class called take animal. They're two overloaded methods. And in the dog class I have the exact same. Now, if you had an inheritance relationship going on between animal and dog, I would need only one method in the animal class. It would just have to be that one. Okay? If I had dog extend animal going on, I would need only this method. So in this case, we have 4 methods instead of 1. With our employee class, we have 1 method where we could have, if we didn't have an inheritance relationship going on between 5 classes, we would have 25 methods instead. Okay? Are both exactly the same. Okay? So you can see that inheritance cuts down on the amount of code you have unbelievably. Okay? By a factor of 25. Now that's with a very simple, just 5 classes extending each other. That's 1 method takes the place of 25 overloaded methods. Alright? So you should be able to see inheritance is, it's not there to make your life difficult, it's there to make your life easy. Alright, I'm going to put in a comment for this one. So I go to the animal class. So this method can only take a animal object. It cannot take a dog object, as there is no relationship between the classes. So if no inheritance, relationship, instead of a take animal method that can take any animal or dog, we have to create 2 methods in each class. One that takes a animal and one that takes a dog. So we end up with 4 overloaded methods instead of 1 if we had a inheritance relationship between animal and dog. I'm going to put a comment in main as well. Okay, this one method replaces 25 overloaded methods if we had no inheritance relationship of all types of employee. Okay, because you would need 5 overloaded send invitation methods in each of the employee types, and we have 5 different types of employee. So 5 by 5, 25. Okay, 1 send invitation method in the super employee class does the work of 25 separate methods in unrelated classes. Okay. Now, that is, and by the way, if you have, let's say if you have 20 inherited classes and you have a method like this, that's going to be 20 by 20. You have one method that takes the place of 400 methods. If you've got 100 inherited classes, 100 by 100, that is 10,000. You could have one method taking the place of 10,000 methods. Alright? So it cuts down on your code massive. Right? Takes a bit of getting used to inheritance, but when you get used to it, you'll never go back to not using it. Any questions on that? And I'll advise it, go back and look at the video if you're unsure about it. Alright? Because this is all we're going to be doing in the next 2 to 3 weeks. Okay? So if you don't quite grasp it now, don't worry. You will by the end of the next 2 weeks. Okay? So I'm going to move on. So I'm going to go to the flower class, please. I'll just put in here, C animal class for class, for example, of unrelated classes. Alright, so I'm going to go to the flower class. So, where am I? A plant class, sorry, plant class. Go to the plant class. So now I'm going to change plant class. I'm going to change it to an abstract class. Okay, so it's now abstract class. So what can we say about an abstract class? You can't create an instance of an abstract class. Can't use the new keyword. Okay. You can use the reference, by the way. And what I mean by that is you can have plant, my plant. That is fine. Okay. You can have an abstract reference. That is fine. But I can't go new plant. Okay. You can't do that. You can do that. Is everyone okay with that so far? Yeah? So you can have an abstract reference, but you can't have an abstract object. That's only a reference. That's the object. Okay? So you can go down here. You can have, come on, plant, my plant. That's fine. But you can't have, put this in capitals. Okay, so you can have an abstract reference, but you can't have a abstract object. All right. So in this abstract class, I'm going to put in int height string name. Now I'm going to put in a comment here. An abstract class does not have to have any abstract methods, but as soon as you have an abstract method in a class, the whole class becomes abstract. An abstract method can only exist in an abstract class. Now an interface is an abstract class. Okay? So an abstract method, now we're not going to put an abstract method in this class. Alright, we're not going to put an abstract method in this class, but something that every plant does is grow. Okay? And I'm going to say plant growing. Now, something that every plant does as well is it sheds its leaves or sheds its or its seeds or whatever. So shed. So plants shed seeds. Now, I'm going to have another abstract class here. So this is the end of abstract class, end of plant class. What's another name for a flower?
Bush.
No. Can you think of another name for a flower? Shrub. Grant. That's better. So now I have flower in another package here, but so I can't create another flower. So I'm going to go abstract class shrub extends plant. Okay, now that means that shrub extends the abstract class plant. So shrub has access to grow and shed. Okay, and it also has an abstract method. Abstract void pollinate. Okay, so this is an abstract method. It has no body. Okay, so abstract methods have no body, and all subclasses inherit this method, and also the methods grow and shed from plant. Okay, right. I'm going to create another abstract class. End of sub class. I'm going to create another one. So I'm going to say abstract class rose extends flower, or not flower, extends shrub. And it's lowercase a. And this is also going to have an abstract method, abstract void sniff. Now, that means that any class that inherits from rows, it's going to have a sniff method, it's going to have a pollinate method, it's going to have a shed method, and it's going to have a grow method. Alright? So, it doesn't matter whether it's an abstract class or a concrete class. A concrete class is quite simply an ordinal class. Alright? Now, so I am going to create So a type of rows would be English rows, old chaps. English rows extends rows. Now straight away we get an error. The reason being because this is a concrete class, right? And when you extend an abstract class, you have to implement all of the abstract methods that's collected on the way. Imagine it's on a journey. Starts off in plant, continues down to shrub, then comes to rows. So any abstract methods that is collected along the way, we have to implement in the first concrete class that comes across. Okay, so this is the first concrete class we've come across. So that means we have to provide a body for sniff, and we have to provide a body for pollinate. We have to override pollinate. We have to override sniff. Okay, override the two of them. Very easy to do it in the clips. You just add unimplemented methods. So put it here. A concrete class that extends an abstract class has to implement any abstract method in go on. A concrete class, I just finished the comment. A concrete class that extends an abstract class has to implement any abstract methods that were in any of those abstract classes. In our case, the abstract method sniff from the rows class and the abstract method pollinate from the shrub class. Okay, we have to override these methods. We can choose to override any non-abstract methods. And we finish this off when the lads come back from their fag. Okay.
Does it not have to be on both sides of it?
Huh?
Does it not have to be on both sides of it?
Both sides of what?
I know the both to be not.
Both sides of an R.
Yeah, the explanation mark. Does it have to be on both sides of the or for both to be knots?
So sorry.
If not one thing or another thing, does it have to have the explanation mark on both sides if you want both to be knots?
Yeah, you have to have both sides of it. You can't just say not something.
Yeah, it doesn't count both.
It doesn't come to a lot. No, you have to put both sides. I think. Yeah. It is.
Yeah. It would be bracket if you like.
You can bracket as well
Yeah.
to make things easier.
I mean, then they'd both be knots.
No, because what you'd have then if you did it like that, something.
Yeah.
Something else.
One of those circles.
So, if that evaluates true, then putting a not in front of it will evaluate it to false. Do you get that?
Yes. Yeah.
It just changes. That's all it is. So, back. Stefan comes back. Oh shit, I kept recording. Right, in the middle of this video there's a 15 minutes, just forward it on, okay? There's a 15 minutes break of me just muttering. Okay, so. Anyway, right, so we have our plant class. Now, so in the abstract plant class, I have a grow method and it says plant growing. I have a shed method that says plants shed seed. Then I have an abstract void pollinate method in shrub, and shrub extends plant. I have an abstract void sniff inside rows, and rows extends shrub. I don't need to override the pollinate method in here because this is an abstract method as well. You only have to override an abstract method as soon as it hits a concrete class. Okay? As soon as it hits a concrete class, my first concrete class is English rows. It extends rows. That means I have to override sniff and I have to override pollinate. Yes? Okay. You have to give them a body. Now, just the only thing I've changed is I've put in a little print statement for sniff that says plant sniff, and for pollinate, or sorry, this is English rose. English rose sniff, and pollinate, it's going to be English rose pollinate. Now, I'm going to put in its own method inside here. I'm going to say pip pip stiff upper lip. Okay, so it's an English rose, so it's going to be void stiff upper lip. And it's going to be SYSO pip pip I say a rose old chap. Okay. Now, so we can only use the new keyword with English rose. Okay, just put in wherever you want there for void stiff upper lip. Okay, so this is English rose. So, English rose has only one of its own methods. Okay? That's the only method that's unique to English rose. Every other method is got from somewhere else. This is got from the shrub class. This is got from the rose class. Yes? And it also has shed and grow, which are concrete methods from the abstract plant class. Okay? So English rose has access, if you have an English rose reference to an English rose object, it has access to 5 methods. Does everyone understand that? It has access to stiff upper lip, pollinate, sniff, shed, and grow. Yeah? Shed and grow, it gets shed and grow from plant class. Okay?
Sorry, what? Sorry, what is abstract?
Abstract is a class that you can't create. You can't create an object of an abstract class. Okay? And also, it can have an abstract method inside it. It can have an abstract method inside it. It does not have to have an abstract method inside it. Okay? If you don't, because think of this logically, there's no such thing as a plant. Something is not just a plant. Something is not just a shrub. Something is not just a rose. You have an English rose. There is such a thing as an English rose. Okay? So, abstract classes are more about, let's say, animal. You make animal. There isn't any such thing as an animal. So you make animal abstract. You're not going to be creating an animal object. Okay? So the only object we're going to be creating is actually an English rose. Now, if I do something like,
Sorry, again. Public abstract.
yep,
When we extend, English rows extend rows,
yep,
we need to add this override.
yep.
And why we not need for blind?
For rows extend shrubs, for instance.
No, it's extended. Yes.
So public abstract class plant. Okay, that's an abstract class. And then I have abstract class shrub extends plant. Fine. Then I have an abstract method called pollinate. Then I have abstract class rows extends shrub. I don't need to override abstract void pollinate because this is an abstract class. When you have an abstract class and it's extending another abstract class, it doesn't have to override those methods.
Yes, but in English rows, we override
Yep.
from shrub
Yep.
and from rows.
Yep.
Why not override from blind?
Because
It is abstract as well.
yeah, but this is not an abstract method. Grow or shed are not abstract methods. Okay, these are not. So these are not abstract methods. So we do not.
Right. It's only because abstract method, yes,
Yeah.
you need to override.
Yeah, we do not have to override them, but you can. Okay, I can override growth. I can override shed. I've chosen not to. Okay, if they're abstract methods, you don't have a choice. You have to override them as soon as it hits a concrete class.
So we override it not because abstract classes, but because of abstract voids.
Well, they're abstract methods, but you can only have an abstract method inside an abstract class. Okay, so it is because it's an abstract class as well. Okay. Now, so this has stiff upper lip, this has pollinate, this has sniff, and it also has grow and shed. Okay. Now I can go back here to main. Now you can have a superclass reference to a subclass object. Okay, and that superclass reference can be an abstract class. So, for instance, rows, which is a abstract class, my rows is equal to new English rows. Okay, so that's an abstract superclass reference to a concrete class object. Okay, I can't do this. I can't go rows, my rows 2 is equal to new rows, because you can't create an abstract object. Okay, you can have an abstract reference, yep, no problem, but you have to have a concrete object class. Okay, that's an abstract class.
So you only have access then to these
Yep,
others?
that's the next thing I was going to come to. Alright, so this is the first thing we do. You can have a superclass reference to a subclass object, even if that superclass is an abstract class, as we have here. Okay, rows is an abstract class. Okay, however, so that's what we have there. Now, you can't have a rows object, okay, as this class is abstract, and you can't have a abstract object. So new rows will not compile. Okay, so that will not compile. Okay, the reason being because new rows, that's an abstract class, so it won't compile. Now, when you have a superclass reference to a subclass object, the same rule applies. What methods are available to it are the methods that are first defined in the rows class or a superclass of rows. Okay, so that means that English rows has access to, it has access to shed, sorry, my rows. It has access to shed, that's from plant class. It has access to grow, that's from the plant class as well. It has access to sniff. Now, this was so I put in slightly longer comment in this one. This was an abstract method in the shrub class that the English rows class overrode. Okay, an abstract method in the shrub class that the English class overrode. Okay, it had no choice. It had to override this method. Okay. Similar for grow. My rows.grow. So exact same comment I'm going to put above grow. Now, one thing it does not have access to is my rows dot stiff upper lip. Okay, let's go to here. Make sure I have the right one. So here it is. Does not have access to that. Why does not have access to that? Because it's a rows reference to an English rows object. Okay, does not have access to this.
Yeah, not just only superclass.
Yeah.
Object.
As it's a rows reference. So only access to methods defined in rows or superclasses of rows. Okay. You could even do something like this. I could go plant rows is equal to new English rows. Now, that only has access to the two methods, shed and grow. Okay, so this object only has access to two methods, shed and grow. So it does have access to it. Plant rows dot shed, plant rows dot grow. Okay, I could have so it doesn't have access to any of the other ones. So let's say plant rows dot sniff. No access. I could do a shrub reference shrub rose to an English rose object. So what is in the shrub class? I go to plant, I go to shrub, so it'll have access to shed, grow and pollinate. It will not have access to sniff. Okay, so back to here, I'll change this to pollinate, no access to pollinate. And then if I go, oops, shrub, rose dot shed, shrub, rose dot grow, shrub, rose dot pollinate, because shrub pollinate was an abstract method in the shrub class. Okay, pollinate was an abstract method in the shrub class, so it was first defined the shrub class. That means it has access to the pollinate class. Now, but shrub rose dot sniff. So this was first defined in the rose class, has no access. So this one here, this was an abstract method in shrub class where it was first defined. You still can't go home. You never told me. Took off.
Probably when he going to home.
He doesn't smoke shop.
No, but he go home.
I said you could go for a smoke. I didn't say go home.
No, he made somewhere mistakes, so like his code not working. Probably why he gone.
Yeah, but you don't go home if something doesn't work. Oh, yeah.
So if you take, let's say, English rows,
Yeah, well, if
my new rows,
yeah, so
equal new English rows,
yeah.
so we will access
Everything. Exactly.
It's like pyramid. Like
Yeah.
On top,
Yeah.
like bottom one can.
Yeah, and you can choose to override
Everything.
grow and shed if you want. You don't have to, but you can. Okay? So, now there's no use in me starting another topic. So I'm going to, we got through that today. Now that was good going today. I didn't think we'd get through that today. So I'm going to stop the video and I'm going to